millennia, feeling small yet connected to something infinitely grand. And then, out of nowhere, a whisper from the cosmos, a visitor from beyond our solar system, hurtling toward us at speeds that defy comprehension. What if I told you that right now, in October 2025, such a visitor is not just passing through, but challenging everything we thought we knew about the universe? It's called 3I/ATLAS, the third confirmed interstellar object to grace our neighborhood, discovered just this past July by NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS for short. And today, as we sit here on October 5th with the world holding its breath, the U.S. Congress has stepped into the spotlight, unveiling data and discussions that for months felt shrouded in the shadows of bureaucratic caution. This isn't about conspiracy or hidden agendas. It's about science finally catching up to wonder, about humanity's elected leaders recognizing that when the stars send us a message, we can't afford to look away. Let's rewind a bit, because to understand the thrill, and yes, the unease, this object stirs in us, we need to feel the pulse of its arrival. Picture astronomers at the ATLAS telescopes in Chile and Hawaii, scanning the heavens as they do every night, hunting for threats from space like near-Earth asteroids that could one day remind us of our fragility. On July 1st, 2025, a faint blip appeared on their screens, a comet-like streak moving too fast, too oddly, to belong here. At 134,000 miles per hour, it was screaming in from interstellar space, the cold void between stars, where Oumuamua, the cigar-shaped enigma of 2017, and Borisov, our second visitor in 2019, had already left us pondering life's possibilities elsewhere. But 3I/ATLAS, it's different, bigger, stranger. And as it barrels toward its closest brush with the sun on October 30th, it's awakening questions that bridge the gap between rigorous science and that childlike awe we all carry inside. I remember the first time I heard about Oumuamua, that elongated wanderer that tumbled through our system without a tail, accelerating in ways comets shouldn't. Harvard's Avi Loeb, one of the sharpest minds in astrophysics, dared to ask, could this be a sign of alien engineering? Not wild speculation, but a hypothesis grounded in data, pushing us to expand our thinking. Fast forward to now, and Loeb is back at it, dissecting 3I/ATLAS with the same unyielding curiosity. In recent weeks, as amateur stargazers from Namibia to your own backyard setups joined the pros, images flooded in. A green glow enveloping the object, a tail that points the wrong way, toward the sun, against the solar wind's relentless push. It's like watching a river flow uphill, a defiance of the physics textbooks we've trusted for generations. And just days ago, on October 3rd, it zipped within 29 million kilometers of Mars, close enough for NASA's orbiters to turn their gaze and whisper secrets back to Earth. But here's where the human story folds in, the part that tugs at your heart. Think of the engineers at NASA's Jet Propulsion Laboratory, huddled over screens in Pasadena, coordinating with the Mars Reconnaissance Orbiter, a spacecraft that's been our faithful eye on the red planet since 2006. They've captured desk-sized details on Martian dunes. Now, pointed at 3I/ATLAS, they're hunting for clues on a scale that dwarfs our wildest dreams of space travel. It's reminiscent of those Apollo moments, when grainy footage from the moon made us believe we could touch the stars. Only this time, the stars are reaching back. Why does this matter to you, whether you're a casual sky watcher or a die-hard space enthusiast? Because 3I/ATLAS isn't just data points on a graph. It's a mirror reflecting our place in the cosmos, a reminder that space exploration isn't about distant probes or Mars missions alone. It's about us, here and now, confronting the unknown together. And as Congress dives in, with voices like Representative Anna Paulina Luna advocating to redirect the Juno spacecraft from its Jupiter swan song to chase this interstellar ghost, we're seeing democracy meet discovery in real time. No more whispers and closed doors. The evidence, Hubble's haunting images, JWST's spectral fingerprints, is out. shared in hearings that blend NASA's planetary defense briefings with the raw thrill of potential first contact. It's unsettling, sure, but isn't that the spark of true progress? As we lean in closer, let's unpack what this visitor is telling us, anomaly by anomaly, before the sun's glare swallows it whole on October 21st. Breathe with me for a second. Feel that? The quiet hum of anticipation as we edge toward the heart of this mystery. 3. I/ATLAS isn't content to be just another comet. It's rewriting the rules, one improbable trait at a time. Let's start with its size. Oh, that colossal whisper of scale that keeps astronomers up at night. Early estimates pegged it small, like its predecessors, but fresh analysis from infrared glow and brightness spikes reveals something monumental. Up to 46 kilometers across, a behemoth roughly the breadth of a small city, weighing in at over 33 billion tons. To put it in perspective, imagine Manhattan adrift in the void, surviving a billion-year odyssey through cosmic radiation and gravitational tugs without crumbling. Natural rocks that big? They'd shatter like glass under such assault. Yet here it is, intact, suggesting either extraordinary resilience or something engineered to endure. Loeb calls this one of 7 key anomalies, a clue that nudges us toward his Loeb scale, a 0 to 10 gauge for interstellar oddities, where 0 is a boring asteroid and 10 screams artificial intelligence from afar. We're hovering around a 7 right now, he says. Not proof, but a call to keep watching. And watch we must, because the chemistry? It's like stumbling on a factory in the asteroid belt. Spectroscopic scans from ground telescopes and space-based eyes like the James Webb Space Telescope have sniffed out nickel in abundance. But iron? Barely a trace. In the universe's grand forge, stellar cores exploding in supernovae, these metals dance together in fixed ratios, etched into every meteorite that's ever kissed Earth's soil. But this echoes the purified alloys we humans whip up in labs for rocket nozzles or turbine blades. Add to that a sudden surge in carbon dioxide and cyanide derivatives as it warms near Jupiter's orbit, far too early for a typical icy wanderer to stir. It's as if dormant ingredients, frozen for eons, are being deliberately thawed and mixed. Not chaotically, like a comet's passive outgassing, but with a precision that hints at control. Now, lean in closer to the images that have gone viral among space communities. That ethereal green-blue sheen, captured by dedicated observers under Namibia's crystal skies. It's not mere aesthetics, it's C2 molecules, 2 carbons locked in a fleeting bond, ignited by sunlight into a verdant aurora. Early spectra showed none of this. It bloomed suddenly, around September 7th to 15th, when 3I/ATLAS crossed within 2 astronomical units of the Sun, leaping in brightness against all predictions. Half the Sun's width in coma alone, a dusty, gaseous envelope that should follow a neat curve of solar proximity, yet spiked like a heartbeat quickening. Why green? Why now? It's the color of transformation, of hidden layers revealing themselves, evoking those first blurry photos from Voyager as it unveiled Saturn's rings. A moment when science felt like poetry. But the real gut punch, the feature that's got physicists scratching their heads and theorists like Loeb penning urgent essays, is the anti-tail. Every comet we've ever chased, from Halley's fiery return to the icy harbingers of dawn, sports a tail streaming away from the sun, sculpted by solar wind and radiation pressure like a scarf in a gale. It's celestial mechanics 101, unyielding as gravity itself. Yet 3I/ATLAS. Its tail, a cigar-shaped streak 10 times longer than wide, points straight toward our star, a defiant arrow against the flow. Hubble caught the glow first, a frontal haze of scattered light and dust defying the push outward. No natural force explains it. No solar wind reversal, no magnetic quirk. Loeb proposes electromagnetic tricks or internal propulsion, the kind that could channel particles sunward, mimicking sails or thrusters we've only dreamed of in our Mars mission blueprints. Imagine the awe on the faces of the Hubble team as they pored over those pixels, echoes of the emotional highs when Neil Armstrong's boot print etched eternity into lunar dust. This is where Congress enters, not as gatekeepers, but as amplifiers of urgency. In August, amid NASA's planetary defense hearings, those vital sessions on tracking near-Earth objects and bolstering our cosmic shields, Representative Luna's letter to NASA lit a fire. She invoked Loeb's work, demanding Juno's pivot. Why end a storied mission crashing into Jupiter when it could rendezvous with this enigma? The response? A cascade of declassified Hubble shots and JWST prelims shared in open forms, revealing the anti-tail's impossible geometry and the object's retrograde orbit. 5 degrees off our ecliptic plane, a statistical fluke rarer than winning the cosmic lottery. For months, data trickled out amid classification for national security. After all, if this hints at tech from elsewhere, it's not just science, it's strategy. But now, with the Mars flyby fresh and perihelion looming, the veil lifts. We're seeing the evidence. No non-gravitational acceleration where we'd expect it from outgassing, implying a mass so hefty it warps expectations. It's emotional, isn't it? This push-pull between fear of the unknown and the joy of shared revelation, much like the global cheers when Perseverance's microphone first hummed on Mars, capturing the red planet's whispers. As 3IATLAS hurtles on, its path grazing Jupiter in 2026, a reconnaissance tour de force, we're left grappling with the what-ifs. Is it a natural oddity, a frozen relic from some shattered exoplanet? Or, as Loeb frames it theoretically, a probe on a billion-year survey, its anomalies badges of intelligent design. Supported by these metrics, the orbit's precision, the chemistry's finesse, the tail's rebellion, it's a developing frontier, not settled science, but one that echoes our own quests. SpaceX's Starship eyeing Mars colonies, ESA's JUICE probe unlocking Jupiter's moons. In this dance of discovery, we're all astronauts, hearts pounding as the horizon blurs. Time slips like stardust through our fingers, doesn't it? As we near October 21st's superior conjunction, the moment 3I/ATLAS slips behind the sun's blinding veil, silent for months, every observation feels like a stolen glance at destiny. Ground-based scopes in high desert havens, battle glare, and solar maximum flares, while Mars Express and India's Mangalian join the fray, their instruments etching spectra of carbon whispers and dust veils. Yesterday's Mars close shave yielded prelims. No desk-sized craters visible, but thermal gradients hinting at a structured core, not random ice. It's a race, urgent and human, evoking the Apollo 13 ingenuity that turned crisis to triumph. Reminding us that in space's harsh theater, our greatest strength is collaboration. Yet amid the data deluge, let's pause and feel the weight of it all. 3. I/ATLAS isn't just reshaping NASA discoveries or fueling debates on the future of space travel. It's a thread in humanity's tapestry, weaving our stories across the stars. From the Inuit legends of sky spirits to the diverse teams at ESA charting black hole horizons, it binds us, women and men, from every corner of Earth in a shared gaze upward. No gender divides the wonder. It's inclusive, this cosmic conversation, pulling in beginners, sketching constellations, and enthusiasts modeling orbits in code. Reflect on that journey we've taken together today. From a July blip to congressional spotlights, through green glows and backward tails, to a perihelion that could unlock interstellar secrets. We've confronted anomalies not with dread, but with the resilient curiosity that propelled rovers across Martian plains and telescopes to Andromeda's edge. If 3I/ATLAS is natural, it expands our catalog of the universe's quirks, paving smoother paths for black hole probes and exoplanet hunts. If theoretical hints hold, framed as Loeb does, with evidence like that nickel alloy echo or orbital bullseye, it beckons a new era where space exploration meets existential humility. Either way, it affirms our place. Not conquerors, but curious kin to the cosmos, dwarfed yet daring to dream. So as this visitor fades temporarily from view, carrying its mysteries toward Jupiter's embrace, I leave you with this. What stories would you tell a starfarer from afar about our blue marble, its ocean's roar, its people's poetry? Ponder that. Let it stir your soul. And if this dive into the stars moved you, hit that like button to fuel more journeys like this. Drop your thoughts in the comments. What anomaly grips you most? Could 3I/ATLAS change everything? Subscribe for the updates as it emerges anew, because the universe isn't done speaking. We're just learning to listen. Until next time, keep looking